Let's continue our discussion of the timing for offset crank slider mechanisms. In this case here, if we understand the basic concepts of the link 2 and 3 being either extended or overlapped, then looking at this geometry, we can see if those two positions are placed on the same drawing, you can see that there is an angle between the two positions. This is called the imbalance angle and represented by beta. Now, if you know that much, then you will be able to determine many of the requirements for the actual timing of this mechanism. So if we take a look at the timing pieces here, we first have delta t. Delta means change in, so it's the time of one complete revolution of the crank. The delta t is composed of two other pieces. The slow stroke, which would be the stroke that would come out or going towards the extended position, and T2, which is the quick return stroke, and that those two are the two strokes that you have in a cycle. Q is a timing ratio, and beta, of course, is the imbalance angle, and that's between the two positions when it's extended and when it's overlapped. Now, what we wanted to accomplish are a couple of things. First, they discover what Q is. And Q, as I said, is a ratio between the two timing cycles, the slow and the quick. The textbook lists them as S and Q. Then they also list them as 1 and 2. That's why I have them written this way. So that when you're looking at the formulas from the textbook, you'll notice that they'll use either of these two allocations. So to find that ratio, we just take the slow stroke and divide it by the quick stroke. There's no unit value here. This is just a ratio number. Now, if you don't happen to have the two timings, the quick and the slow, then you can use the beta angle. If you happen to have the beta angle, you can also find the timing ratio this way. Depending on what you're given, then will be determined as to how you can discover what Q is. Now, the second thing is, you try to find beta. You can find beta if you know Q. So these are all interchangeable kinds of formulas. Depending on what you want to find and what you know, you can use these formulas here. So beta can be discovered this way here. Now, you may have to find the beta angle using trig. You can do that by taking the position of this pivot right here and drop a line straight down and then bring this line over across, and you have a right triangle. So you actually have two right triangles. You have this triangle here that you can use. That would be for the overlapped angle. And then you have this triangle out here, which will get you the angle to the extended position. So just by using your standard trig functions, you can find beta. But if you're given Q, you can find beta. So depending on what you're given, again, you got to look at what your givens are and then use your knowledge of trig in order to solve for that angle. Now moving on then, if we want to find the relationship between the crank and the timing of the mechanism, you can use a very simple formula. In this case here, W means the crank speed, another going around. And crank speed is generally given as RPM. It might be RPS, revolutions per second, but generally cranks are listed as having an RPM. Now, the reason I have this formula here with 60, because I need to convert the revolution, the timing in seconds to minutes in this formula. Because timing generally in this application is all in seconds. Okay, so we'll have to convert those seconds into minutes once we get to this timing of the crank going around. So now if we do have, and we want to discover what that total timing is, it's 1 over W times 60 seconds per minute. Or, of course, you may be even given both of the two stroke times, and you can find out what the total time is here by just adding the two stroke times together. Now finally, another combination of, depending on what's given and what is not, is you want to find what the timing of the two strokes are. So we can use this formula here if we know Q and delta T. And then we can find this one if we know T1 and Q, we can find T2. So with all of this information, depending on what you're given, you're able to discover how fast this mechanism is going back and forth, or how fast the crank is going, in order for you to plan this in a, say, mass production situation. So that's basically it. You have all the tools you need here. Now that we've discussed linkages and offset cranks, and you ought to be able to follow through with these processes for timing. Very important. All right, thank you very much, and let's see what we can do with this.